This is FLOSS Weekly. I'm Doc Searls, and this week Jonathan Bennett and I talk with a man who needs to rule the world, and he said that at the end, and he's correct. His name is Dave Taht, and he is the primary reason that Bufferbloat will stop slowing down and complicating your internet connection. It is the biggest culprit in the world right now for why your internet doesn't work as well as it should, and he's the guy on the case. We talk with him about that and so much more, and that is coming up next.
Podcasts you love
from people you trust.
This is TWiT.
This is FLOSS Weekly, episode 638, recorded July 14, 2021. Bufferbloat and beyond. Good morning, good evening, good whenever it is, wherever you are in the world. This is FLOSS Weekly. I am Doc Searls, and I'm joined this week by Jonathan Bennett. Morning.
Hey, Doc. Hey, how are you?
I'm good. And you're in your increasingly equipped lair in Oklahoma.
Yes. We'll talk a little bit about that some more at the very end of the show when I go to plug things. But yes, we've gotten an upgrade here. A little bit of cyberpunk purple going on behind me.
It's very good. It's very good. And then now you need animated characters flying around and doing crazy things. So yeah,
that's an
I
interesting
think
idea.
You'd probably improvise some stuff there.
Sure.
So we have many topics this morning with Dave Taht, our guest, who we'll bring on in a second. But if you've been following a bunch of this stuff, what's your launch point on today?
Oh goodness, there's a lot of things. So when it comes to David, I've known of him. So preparing for this is the first time I've got to actually meet him. But I've been kind of in the same orbit as he's been for a long time now, because he's one of the things he cares about is OpenWRT, or OpenWrt as he calls it. Mm-hmm. Everybody pronounces that a little bit differently. And I remember back, probably 10 years ago, he came out with two different things. Started talking about Bufferbloat, which I think is something we'll talk a lot about today. But also, the FCC was talking about forcing router manufacturers to lock down the firmware on routers, which would basically kill OpenWRT, the way that 90% of the people deploy it. And so he kind of led the charge to go back to the FCC and say, this is a bad idea. It's not going to fix the problems you think it will, and here's why. And actually had a really good result out of that, which I hope we'll get to cover. But yeah, I'm excited to actually chat with David today.
He's had a lot of good results. The problem with so many good results is they take time. And we'll touch on that. And touches that as well. Let's visit some quick news before we start. You start with yours, because I know you've got something pressing there.
I do have something that's really interesting, and it kind of goes along with the show today, because if my audio dies all of a sudden, it's because I am running the 5.14 RC1 Linux kernel, compiled it myself, because they finally fixed the FireWire audio drivers. We don't have to get into the nitty-gritty about what was wrong, but let's just say that the old version of the kernel was trying to tell the FireWire driver to play audio in the past instead of the future. And that just doesn't work out very well. But that is actually fixed now. And goodness, if you have old FireWire hardware running around, it now works really well with ALSA and therefore with Pipewire, which, is something else that I'm super excited about. So that's my news for today.
Wow. I cleaned up a bunch of open boxes I have in my office. And among those things were at least 4 FireWire drives, hard drives, and an uncounted number of cables. I had 2 cubic feet of cables. I measured it, of tightly packed cables I had to pull apart. And there was far more USB cables than there were FireWire cables. But there are enough FireWire cables that I just put them in a box with the drives and went to the basement. But so I don't have a need for that right now, but it's good to know that got solved. And the only piece of news that I have is one we're going to touch on, which is that right to repair became a matter of high interest in the U.S. government. We don't get political here, but it is a it's an important topic. Cory Doctorow has covered it a great deal, and Dave has been all over it. So with that said, let's get to our guest, Dave Taht. I'm going to read down, I mean, I've known him a long time too, and there's so many things, but I'll just read down a paragraph he sent to me. He's been kicking around the internet since before it was spelt with a capital I, and now after it's been spelt that way. I still use it that way. He worked on Xenix, founded a Linux-based ISP in the early 90s, sometimes credited with the co-invention of the first embedded Linux wireless routers. In 1998, he helped launch Linux into the embedded world, and in the aughts at Monte Vista, a name I had not heard in a long time. And I'm wondering if I met you, Dave, during Monte Vista. And as part of the One Laptop Per Child project, he ran head-on into his bête noire, the Bufferbloat problem, while in Nicaragua a decade back. And ever since has been inventing and distributing algorithms to cure cancer with better open word, as he pronounces it, based routers, IETF standards, and outreach. And so I know he's not on the level because he's in a sailboat right now. So come on in, Dave. There he is. He's not tilting one direction or the other.
Yeah.
But he's there with his guitar behind him, with the bumper sticker he proudly displays that says this device kills. There he goes. Kills Vogons. And for those who don't get the reference, this machine kills Vogons. That harks back. Yeah, exactly. And it's not just that, but to Woody Guthrie, who said this machine kills fascists. That was the Vogons of his time. So welcome, Dave. And I don't even know where to begin. So why don't we just begin with right to repair, just because I mentioned it, but you go and then go there to open word, however you pronounce it, and there's too much to cover. So let's start with right to repair.
Yeah. Oh man, that is a huge topic, and I care really deeply about that. I'm in a sailboat. I have most of the gear on here is 30, 40 years old, and I could fix all of it still. But I get a router from, I don't know, you might have seen this one, and I can't. And that really bothers me, that we have to, going back to the Woody Guthrie reference, do you know his famous song, "This Land Is Your Land, This Land Is Our Land"? Mm-hmm. Yeah. You know that one? You know the copyright? Have you heard the copyright notice he put on that one?
No.
He basically says, sing it, yodel it, do whatever you want with it. We wrote it. That's all we wanted to do. Go do whatever you want with it. You know, it was like the early Creative Commons license, essentially. Mm-hmm. The thing that song is completely tied up in copyright hell today, despite that notice. You're not allowed to play it, even though he explicitly gave it away. And we're in that position with Linux in particular, where we gave away all this beautiful code under the GPL and other licenses, and then somebody wants to rent it back to us. And it used to be we had this cooperative environment where we worked hand in hand with the vendors, et cetera, where we gave them patches, they gave us back source, we kept improving it, things got better and better. And over the last 6 years in particular, people seem to have, the vendors have forgotten that this is a cooperative environment, that this code is our code, this code is your code, this code belongs to you and me. And it's frustrating. And I want to somehow restore the right to repair, and the right to inspect the code, and the right to improve the code that we seem to have been losing in the Linux world today.
Hey, Dave, I'll jump in because I've seen something really similar to this, and I think it's related. A lot of times you have a vendor that is built either just an SoC or even a complete board that's got the processor, the Wi-Fi chip, and all these things on it, and they will generate Linux support for it. But what they tend to do is they will grab probably a long-term release kernel from 5 years ago and dump all of their patches on that, and then throw that tarball up on an FTP server somewhere and say, oh, no, we complied with the GPL, which is technically true. We complied with the GPL. There it is. And then they just kind of wash their hands of it. And then you have Linksys and Starlink all of these guys, TP-Link, all the vendors will then go, oh, well, here's this nice Linux kernel from 5 years ago that just works with this hardware. All we've got to do is put our web interface on top of it and we're done, ship it. And it drives me nuts because it's not that hard to work with the Linux community and actually get your patches upstreamed so that we can run halfway modern kernels on our hardware. This is something that drives me nuts. And I have a feeling it irritates you as well.
We're talking about my face turning red with just, my blood pressure every time I see something. It is not hard to work with the community. It is best that you work with the community. And going back to the FCC thing that you mentioned earlier, and then move forward in time to where we are today, I was working on making Wi-Fi faster. I had a project called Make Wi-Fi Fast. We'd invented an algorithm that cured Bufferbloat and Wi-Fi, made Wi-Fi 2.5 times, use bandwidth 2.5 times better, and have 50 times, not 50 times less latency with multiple people on it. It was beautiful. It wasn't done yet. And all of a sudden the FCC said, oh, by the way, we think you flashing your own software on the routers is a bad idea. And I had a bird. That was the first major political action I'd taken in a long time. And I called up everybody. I mean, here's a scene in The Professional, right? Bring everybody. And I did 260 plus people that were founders of the internet and said, this is a really, really bad idea. And I co-authored a piece with Vince Cerf that we submitted as a filing. And then we bought some PR. And cool, I got a free ticket to go talk to the guys running the FCC about 2 days later.
Cool.
Lost 6 weeks of my life for this. So I flew over there. We had a nice talk. And I flew back about a week later. You can probably Google for Vince Cerf router. That was the initial broadside. And and they backed out. And then about 8 months later, we finished fixing Wi-Fi for that chipset. And cool. But in winning that one battle, we still lost the war in two ways. The FCC more or less basically said that the binary blobs that went into 802.11 AC and AX and so on were what they wanted. And that those blobs have gotten bigger and bigger and bigger and more terrible. And they're in an infestation on the quality of the Wi-Fi we have. I still have, Sasha, could you hand me the other router over there? Thank you. We adopted this particular router. It's a Netgear Wonder 3800. It's built out around it's entirely 100% open source, top to bottom. And because of that, we were able to innovate and not just fix Wi-Fi, but we also made IPv6 work a lot better. This is over 7 years ago. And one of the things that I'm a big believer in is quality. I have a couple of these that have been running for 7 years with the only outages being power failures. So building a box that just sits there in the corner and blinks and you never have to think about is always my goal. And that's very different from the vendors that want to sell a new box every 6 months. I kind of view the internet as a utility that, how long does your heater last? 15 years. Well, how long should your router last? 15 years would be a good start. And I'm well on my way to that with just these guys. Somehow getting the software quality up, finding some way to have things that you don't have to fiddle with ever that do good things has always been my goal. And I'm really still not sure how to get there, but I fully expect to be able to still run these things in another 10 years and they'll still be pretty darn good routers. And that's a ongoing software development process with continuous updates and other things that the entire structure of the embedded router market doesn't do. They sell the one box, they give you a piece of crap kernel, they give you this, and then they leave. And somehow people need to be aware that there is a ongoing development cost that the software that we keep building in OpenWRT, I'll explain why I say wart later, is good stuff. It's craftsmanship, it's quality that we just keep building into things and improving them. Like I said, I'm pretty passionate about trying to get back people's hands. Anyway, go ahead. I'll stop now.
This is one of these shows that's going to be better in video, but I just have to show this because this is my version, my copy of that very same router. Those of you listening can't see it. And it's one that Dave gave to me, and I used at our house until I had to put in some new stuff. And I was going to get it plugged in this morning and put it in this chain because I finally recovered enough Ethernet cables last night from my 2 cubic feet of tangles to do that. But I missed the window. But go into you said you go later into the open word thing a little bit more, Dave. So go ahead and do that. And then Jonathan, because you're involved in that too, you might want to expand on that as well.
Me? Jonathan? Me?
Go ahead, Dave. Go ahead and tell us why. Start off. Tell us why you call it open wort.
Okay. Well, it's Serawort. So it was really obvious when Jim Geddes and I started the Bufferbloat project that the biggest problem that the IPv6 rollout and Bufferbloat had was that nobody was making good routers. They were shipping ancient kernels with lousy support, and deploying IPv6 in particular really required serious advancements to get that in the hands of real people. And we went around with hat in hand saying, hey, we want to go build better routers. Nobody funded us. So we just went ahead and did it. And I also had this quality OCD thing that I have. I wanted something I could just plug in a corner and never think about again. So I called it Serawort, the Spanish word for zero. Warts, 0 warts. And so we started this cooperative project with over 100 volunteers to separately spin up all the changes that we needed to make OpenWRT work, proving out a whole bunch of really theoretical things. At the time, nobody thought that an active queue management could be run on a home router. It's too complicated, too expensive. Nope, existence proof. We fixed that fq-codel algorithm. And so we spun up this project that all these wonderful people involved. We tested it all worldwide. And then when it was finally done, instead of commercializing it or doing anything like that, we made sure all the patches went back into OpenWRT. And then I took a nap for a while. And a lot of, at the time, even the open word devs, we were saying we were 5 years ahead of everybody else, and including them. And that was great. We were looking, the future was so bright. Do I have sunglasses on the boat? Anyway, the future was so bright that we needed to wear shades. And I really felt that way. I thought that we made a breakthrough, and I thought that the world was going to go immediately and start upgrading all their old routers to OpenWRT and get IPv6 going. And boy, was I wrong. But
before I was just going to say, before we continue diving into that, let's actually define a term. What is Bufferbloat? That's just where routers in the chain have too much memory given over to buffer, right? That's what Bufferbloat means.
I brought it down today. This is my clue stick.
All right.
Sasha, could you second?
Whack us with the clue stick, sir.
Okay. So the world, the CEO of Ruckus, said fairly recently, we've got the biggest buffers in the industry. And that's not what you want. You really want to have a matching of the input rate, which is gigabits per second, to the output rate. And it's a really simple concept. It really, really is. You take this thing here and pour from the tippy top as fast as you can.
As fast as I can.
Yep, fast as you can. Well, no matter how fast, stop. Please stop. Okay, great. And then pour it back in there. No matter how much stuff you stick in here, it's going to come out of here the same rate. Okay? And ideally, for voice and video and VoIP, what you want to have is the smallest buffers possible so that your interactivity remains. You need 20 milliseconds of buffering tops. So if you can do that again, but much slower, okay? If she dribbles slower than that, even slower. So she's dribbling like that, then there's room for voice and video to fit in. But if you dump it in like that, the backstop and the backlog gets in the way of everything else interactive that you do. And that's in the crux of the Bufferbloat problem. It's mind-boggling that anybody would not understand that really big buffers are bad. You want to have the interactivity. But the whole industry just went the other way. And been fighting that one for a while. The thing is, we did win then. The fq-codel algorithm in particular is the default in all of Linux. It's the default in OS X and every. Actually, everybody on the show, do this. If you're running OS X, type in netstat -QQ space -QQ space minus capital I space whatever your network interface is. You'll see fq-codel there. If you're on Linux, type in TC -S QDisc show, QDISC show, and you'll see fq-codel there. Great. So all of your packets from this wonderful research project, almost everybody on the show is running through algorithms that we designed in this wonderful thing there that we pushed out to the world. And, if you like that, send me $1, or I'll send you a sticker, whatever. The thing was is that as hard as we tried to eliminate the Bufferbloat problem with this stuff, people kept piling on more buffers. It takes 5 years or more for a kernel to get out. And sometimes people just forget to turn it on. And in particular, the core place where we needed this algorithm was on home routers and on head ends, which means that your video conferencing and your VoIP and your gaming would always work. And your downloads would slow down by a tiny fraction. And that's why, in part, I've kind of come off my boat in the last year, in the last couple months, because, wow, I went to a coffee shop as soon as COVID ended, right? And I started to download, and I see people's heads pop up from their laptops because there was over 1.6 seconds of latency built in to that coffee shop's buffering. And it's not needed. And I don't know, I'm almost incoherent with how frustrated I get. You hit Y in the kernel 3 times and you're done. We have another algorithm called Cake that is even better than fq-codel was. Can I stop now? Have I finished ranting? Did you guys?
I'm going to
come hour to go. So
I've got follow-up questions. I'm sure Doc does too.
Please follow. Yeah.
So we have a live chat in the IRC, and we've got a question from there. Actually, Jojo Dancer wants to know. He says, how do you change the hardware of your router that's designed that way? So the amount of buffer that's built into your router, that's kind of set, right? What's the process to get rid of some of that?
It's all software, man. It's just software, lots of software. And it's almost all, at least in the routers I work on, it's all open source software. So the pieces of hardware that are difficult to modify, like I said with the FCC, the binary blobs have all the buffering in them for Wi-Fi now, and we can't fix those. We have to just please don't over buffer in those, or we have to keep renew the push to make open source the default in the world, so that we can engage the right to repair to fix things, to make them better. So is that a reasonable answer for your IRC guy? Nice to meet you, Jojo Dan.
I think so. So you mentioned, I want to follow up on this real quick. We normally do this at the end of the show, but you said it. You said anybody that wants to make this better or appreciates your work, send you $1. How does somebody do that?
Thank you. I have a Patreon page. It's just my name, or you can look for Make Wi-Fi Fast. I've got 2 of them. There's also a what's the other one? There's Patreon, and then there's GoFundMe. So my name is pretty unique, and you'll see my work there. I've done a lot of educational videos too. Don't send me $1. Sit down and suffer through one of my videos. Did a really good one. Google for AppNic, APNIC space Bufferbloat, and I give a wonderful demo using people with packets as how the internet's supposed to work. And to me, it's really intuitive how it should work. And after explaining it too many times over the last decade, I'm obviously, a funnel right here. You need a small funnel, not a gigantic. This is my clue bet, like I said.
All right, so let's dig a little bit deeper into this, because this is something that I'm not sure I entirely understand. The solution then for Bufferbloat, obviously you want to deliver packets faster, even if there is a lot of traffic. So is the solution to drop packets that are the ones clogging everything up? Or is a solution something like end-to-end quality of service? That's not really practical, is it?
The latter question is end-to-end quality of service cannot work because of a lot of stupid decisions that we made along the way.
I think really part of that is everyone would say that their traffic is the most important. Isn't that really the problem there?
It's part of the problem. Can I dig just a teeny bit deeper on that before answering your first question?
Go for it.
So we created a field for type of service going back to ARPANET, where we had categories of service that seemed to make sense to the engineers. But the end users typically said, no, my packets are the most important, and it didn't work out. The only category that I truly of quality of service that I actually think is worthwhile is background traffic. I want this upload or this download. It could take as much time as I want, but my God, I want everything else, like my video conferencing, to just work. That said, so they created the diff-serve standard, which was incredibly complicated. I know one of the authors of that, she deeply regrets doing that. And one of the things that happened along the way, which killed the end-to-end argument, if you're familiar with that argument, was that it was created as a per hop behavior. Every person, every entity along the path reserved the right to modify those bits before they reach the endpoint. If we had somehow said, no, only the end user, like me on my boat, I'm allowed to mark my voice packets the way I want to, and I hope that everybody along the way will respect that. No, it's every man for themselves. And that killed quality of service entirely for the internet. If you can't get quality of service, well, what can you do? Now, the internet is a string of protocols designed by some really brilliant people over the last 40 or 50 years. We screwed up multiple times. There was a thing called source quench. There's something where we were way wrong. Go Google for that someday. The internet was down 1986 or so, the whole thing. And everyone was busy writing proposals as to how they might fix it, or saying, the internet's a bad idea, you should go back to using something else. And Van Jacobson and Mike Carrolls came up with the algorithms that govern how we have different kinds of traffic share fairly. Now, honestly, everybody that's writing a protocol working on the internet should have read that paper before being allowed to drink and drive on the internet. Anyone doing it, and very few had. It's called Congestion Avoidance and Control. So if I get 3 more people to read that, that's probably 3 more that's read it in the last year. And that had all kinds of neat algorithms in it. Now, finally getting to the larger point. We have 2 different kinds of traffic. We have voice, which is, I'm not used to radio. So every 20 milliseconds, a voice packet pops out. It's really tiny compared to everything else. Less than a megabyte, a couple 100K tops. And then you have video, which typically is about 4 megabits tops, typically under that. And then we have, it's called capacity seeking or greedy traffic, and that's TCP. That like protocols, and that goes out and tries to grab all the bandwidth it can. And if it experiences a drop, it's supposed to drop its rate in half. And that's a mathematically stable thing, where 10 flows will ultimately share the bandwidth correctly if they're short buffers, which is what we had back in the 80s. Nobody thought that we'd have more buffering than that. So there's 2 different techniques. The most important one, am I lecturing too much? Again, I could do this one.
No, not at all. Keep going. That's good stuff.
There's a really important technique. The most important one that I think is called fair queuing. It's not a really good name for it, but what it does is it does better statistical multiplexing. And let's see, what can I do for it? Get pictures. So you had that little VoIP packet, right? And you had this enormous flow consisting of Netflix packets. And the VoIP packets arriving at every 20 milliseconds, and the Netflix flow has got this. Well, fair queuing means that you're every single time that VoIP packet arrives, it gets interleaved with the other packets. So it never ever sees that enormous Netflix flow. And you do enough fair queuing. We use 1,024 queues, not 2 lanes of traffic, 1,024 lanes of traffic. And if you got your bicycle on there, and if you got your motorcycle on there, you get equal priority with the big fat trucks on the internet. And it's a very common technique. It's one of the things I deeply regret in that we started sometimes I get credit with helping invent the first Linux wireless routers, and that's a good story. The thing is that my roommate had a girlfriend that loved to play this particular game that completely saturated the Wi-Fi link, and we couldn't do it. And when we added fair queuing to it, that's a picture of my people as packets. That's cute. It's a great demo. And I had a ball. With it. I still feel a little bad. I had a canned joke where I picked on somebody more than once. I intended to pick on multiple people with that, but I think she'll forgive me someday. Anyway, so fair queuing is the most important technique, getting the best statistical multiplexing you can of all the different kinds of traffic you have. And when we had short buffers, that worked. When they have longer buffers, you absolutely must put that into your system. And it's no different from you multitasking a conversation with someone. I talk a little with Doc, I talk a little with Jonathan, I talk whatever. So long as you do that really, really fast, it's totally invisible to the end user. Okay, second one, or should I stop?
So I had a follow-up question here. We'll get to that other one here in a second. But follow-up question again from Jojo. He says, essentially, if I don't want to mess around with putting my own firmware on a piece of hardware, is there anybody that gets this right?
Oh, yes. Okay. So again, that project ended essentially we upstreamed everything in 2013. So for starters, it became RFC 8290 and 8289. So they're internet standards now. And a lot of people shipped this stuff starting right then. So, for example, Eero. The Eeros 5, the first Eeros, almost all the meshy Wi-Fi routers ran this stuff. Now, the newest one from Eero doesn't, and I'm angry about that, but ran this stuff. You can pretty much get it from ASUS, almost all the gamer routers. They talk about prioritization in their QoS and all their deep packet inspection. Underneath the thing doing the real magic is fq-codel. Puma, for example. It's fq-codel. All the other stuff that they do is just marketing gloss. There was another, while I'm ranting, there was another wonderful product, Stream Boost, that was built around this stuff from Qualcomm. And it won an award, and it did all kinds of great stuff. And again, the marketing people thought that, look at all our prioritization and QoS and deep packet inspection. That's what's doing the job. And they forgot to put fq-codel in one of their releases. They had the brand Stream Boost. And it didn't work because they forgot to put in the fundamental component. They misled themselves. So yes, off the shelf, many, many, many routers do this today. It's certainly well beyond OpenWRT. I like to be running more modern kernels in 5 years. But I'm pretty sure 4 out of the top 5 manufacturers, almost always in their gamer routers, have it, and so on. So it's a pretty good answer.
Yeah.
Okay.
All right. Go for it, Doc.
Yeah, I have a small question, and I know Jonathan has another in his buffer. Probably a lot of them. I hope it doesn't bloat, because we only have you for an hour, Dave. It ain't enough.
I personally think pack a buffer, so don't be too dilatory, okay?
So a question I have is, why, when you've got an obvious answer to a simple question and it's a technical answer, you have some code. It's all software, like you told Jojo Dancer earlier. And why does it take so long? Is it just institutional cold feet? Is it just bureaucratic dragging? Is it cluelessness? Is it protectionism? Is it lawyers? What is it that makes companies act so slow, even when you deal with them directly?
You see, you just overflowed my buffers. That was 7 different things.
You kept track.
Somebody write down this. I need to work back, pop your stack there. Lawyers, for example, a lot of people were brandishing the patent thing. In fact, one of the earlier attempts at this was touched upon 3 lines of code that were patented, called SFQ. Similar idea we put into fq-codel, but there's patent attorneys at the ready for something that we put in there. And they've been, they're not a problem. We have a I worked with OIN, Open Inventions Network, to solve that problem thoroughly. So if anybody has a patent case against these algorithms, all of us that helped invent the internet worked together because we solved the 50-year-old problem with this, and we wanted to give it away. Van Jacobson, Vint, myself, Kathy, Jim, we all said, you've got to give this away. And we worked really hard to unpatent it. Now, there were 6 other items on the stack. Why is it taking so damn long? There was a Twilight Zone episode. I can't remember the one where everybody was disfigured, right? It was a long time.
Yeah.
And 2 lovely people showed up and they were treated as ill. And so nobody except maybe us old farts have ever experienced an internet that was almost always fast. People were very used to suffering. I'll just sit here. Hey, kid, get off the internet. I'm trying to take a phone call. They just don't know that it's possible to have an amazingly different and improved internet experience all the time. So that fundamental gap of identifying that why is the internet slow today? One of Jim Geddes' better pieces to this stuff. Oh, I just need a better router to create using user demand is not really there. And that's partly why I'm trying to do outreach and try to explain stuff better. And the other one, why are ISPs slow to do it? I've become deeply cynical over the last couple of years. There's a big thing where they're selling you more and more bandwidth. That's their only thing. That's their only market differentiator. Oh, you got a problem? You need more bandwidth. The thing is that that's not really how it works. The engineering the internet to speed test is a dumb idea. It doesn't reflect anything resembling real traffic. And in fact, we have people go do a speed test and take a packet capture with Wireshark and look at the TCP RTTs. Simple. Why don't people do that? The RTTs aren't supposed to inflate to seconds. They're supposed to be milliseconds. And the thing is that once you have a network that's acting that badly, the ISPs can turn around, sell you more bandwidth because that'll make the problem go better. And it sort of does until you do a bigger upload. So I don't want to be quoted out of context. Okay. For web traffic, nobody needs more than 50 megabits of download, period, today. Because it's not, people think about round trips, and it's like you have one packet, you get back 2 packets, you get 1 packet, you get 4 packets. You have this curve that goes up over time, and how it works when we look for capacity. Your typical web page is about 3 megabytes in size, and it takes about 3 seconds to load. And if you do the math, you don't even need more than 20 megabits with most latencies to actually download a web page. You can't use it up. And if everybody had bought a better router and had 50 megabits down, 10 megabits up or more, the internet would, for most purposes, feel really good all the time for a family of 4 or 3 people in a boat. It would just be there, and that would really hurt ISPs' profit margins. That said, ISPs in competitive markets have done really great things. Free in France, in particular, deployed fq-codel 3 months after we developed it, and into their DSL market. It was great, and more recently. So people, a little. Okay, so I talk about the negativity of some ISPs. Believe it or not, Comcast has worked really, really hard to reduce the observed latencies on their network over the last decade. And they've pretty much finished rolling out another algorithm called Pi across all of their users who didn't really notice. They just noticed the service got better for all kinds of traffic, and they did it. I got to give praise to Jason Livingood and Comcast Research for making that happen. And so if you're on Comcast today, your latencies are pretty good all the time. If you're on any of the other cable services, I'm not allowed to curse on the show. right?
Ideally not, yes.
So, and at the same time, can I keep wandering down that one? Because it's very frustrating.
Sure.
Finished 8 years to deploy that across 20 million devices. Cool. A lot of different devices, a lot of work had to happen for that to happen. And there's a paper pending that I participated on. And they use this other technology called, I love fair queuing first, AQM second. They did AQM first and they're considering fair queuing. So they use the Pi AQM, active queue management. And their PR and marketing departments are so scared of the idea of the net neutrality people, forming pitchforks to come after them for doing active queue management. It's a technical term to make the internet better. That they buried the report on me. I'm really proud of. Really proud of what we did there, and it really helps. It really works, and so one of my hopes is that I've had a couple rants. So I have another blog. It's blog.sarahwart.org. I have a rant where I took on both sides: the ISPs that were unwilling to deploy upgrades, and the network neutrality folk that were creating political solutions to what was really a very deep technical problem that had plagued the internet for 50 years that all these would be fixed, and one of my goals in the coming months is to try to reach across the aisle and get the ISPs and the network neutrality folk say, yes, by the way, this is a really good upgrade for all of us. Let's make sure we make that happen. And I hope that it's really easy to demonstrate. I mean, Doc, you've got my stuff. It really helps to make the internet better. And anyway, it's enough of a rant, I guess. Sorry. There was like 5 other things, Doc.
That's all right. Hey, I wanted to ask you something. Essentially, what this does when someone puts OpenWRT on their router, ZeroWart, to fix this, they're controlling their upstream and downstream bandwidth to give the right packets priority. Doesn't that really only work on the upstream bandwidth? Can you fix downstream buffer bloats on your own hardware, or does the ISP have to be involved?
Well, boy, I get that a lot. No, if I had to wait for the ISPs to fix it, I would have. No, you absolutely can and should try to manage your own bandwidth on inbound and outbound. Outbound is one of the biggest problem that we see shows up. Do a big upload and you'll see 400 milliseconds or more of delay and everything slows down. But on the download, you can take back control from your ISP if you care about your interactive traffic. And I like to think that most people care more about their video conferencing and web traffic than they care about the speed of their downloads. I know maybe I'm weird, but I don't care about the speed of my downloads. I want to make a phone call. And so you put an inbound shaper on it. The big algorithm these days is Cake. That's a successor to fq-codel. And it does all kinds of really great stuff. It's a little CPU intensive. So taking a huge step back, fq-codel at line rate, 100 megabits, 10 megabits, the native rate of the interface is almost completely doesn't use any CPU. It's great. However, if you want to do inbound shaping, which is like 200 megabits or 300 megabits, for example, this is it's an old box. This can do about 70 megabits tops. Newer stuff can do about 300 for inbound shaping, and you absolutely should do that. And you can get x86 gear to do a gigabit. So you can get, I don't have one on the boat today, but you can get an x86 box that'll do it for about $200 or reuse an old laptop. But ideally the ISPs would be doing this at their head ends. They're already doing they just using FIFOs and it's someday all the world. And I do want to. How much time do we have? I wanted to talk to this at some point.
You want to pivot and talk about Starlink? That's something that was in my buffer.
Right.
So let me set this up. Let me set this up for you. You're using internet on a boat. Are you using Starlink right now? Is that your internet connection?
No, I've been using the boat as a 5G, 4G floating test bed for the last couple of years.
All right.
I've been working on devices like these. I'm not allowed to talk about most of that work, but I'm hoping if 5G get better. Backstory. Okay. Let me get composed because I lost my stuff on this one, and so I had heard. So I had actually emailed Elon Musk back in 2013. I said, "Hey, we're going to fix Bufferbloat. You interested in helping throw some cash in our direction? You might have a better internet." He said, "No, I'm too busy with SpaceX and too busy with Tesla to even think about it. Sounds cool." And I'm like, I'm a huge space fan, and I said, "Elon, it's okay. I forgive you for blowing up my satellite." So I'd worked on a satellite Trailblazer, and it went up on the Falcon 1's third launch. And I don't know. See, it was the greatest 160 seconds of my life before they bumped it, blew it up. But I forgive you. I'll go work on the internet now on my own. You can go solve the space program thing. We're even. Anyway, and I'd heard that Starlink was going to use OpenWRT. So they promised it was going to be low latency this and all these other wonderful promises they were making public. It's like, it's OpenWRT. It's going to work. And I didn't care. I was like, I'm happy. And so then I got a call from my godson who just got one. And he said, "Houston, we have a problem." And it turned out that they had, I don't know what they did. They dropped, and there's a crappy version of OpenWRT they were trying to use instead of the modern one. They dropped that, and they forgot to compile in fq-codel. And I got back traces showing that uploads had over 400 milliseconds of latency. That's 1.5 times around the planet, okay? And you're around 6 feet of your connection. It doesn't need to be there. We've solved this problem. And it was really bad on the downlink, too. I forget what the number was, over 300. And the Wi-Fi at distance, again, distance, the inverse square law means the further away you get, the less signal you have, was over 7 seconds. Almost all of our internet protocols were designed with a timeout of about 250 milliseconds before they start sending more packets. And I went up there and I did a string of tests, and I tried to find a place on the website to file a bug report, hit yes on these 2 algorithms and put in another algorithm called BQL, and you will have the greatest ISP network ever. They're like one of the first ISPs to basically be Linux based. They were in position to just show the world how much better you could build the internet. And I wasn't paying attention. So I looked at the website, couldn't find anybody to talk to. And I said, screw it. I mailed Vint Cerf. Co-inventor of the internet. I said, Vint, do you know anybody over there that could look at this? And he emailed Elon. Okay, cool. That's great. Elon app. And then we had a really good meeting on the boat where we talked about the Bufferbloat problem. And they hadn't really thought about it very hard. They were very much layer 2 communication engineers and not internet experts. And so I gave them the Bufferbloat and Beyond book. Maybe we could put that as the URL, bufferbloatandbeyond.net, which is how all of our algorithms documented and all of them published, and they're all have APIs in the kernel. So I had a wonderful chance to lecture them on this, but I didn't have a whole lot of confidence that it had gotten through. So I started a mailing list. This is what I do. And I brought in everybody, all the founders of the internet that are still alive and coherent. Vint and Dave Reed, who invented UDP. Len Kleinrock, who is an unsung hero of the internet. His books on Q theory, marvelous, brilliant man. All these people that have been around the original invention of the internet, got them on this mailing list at bufferbloat.net called Starlink. And we started typing in all of our advice in the hope that Starlink would listen. So this has been about 4 weeks now. And, I could have fixed this. This is the Starlink router. It has a board. I mean, by the way, Jonathan, wave your board. A board totally supported by OpenWRT, already works beautifully. And if I could just drill into this thing or get them to cooperate with the open source community, we could have made this thing a really great router in about 10 minutes. 4 weeks have gone by, I think. And I have great hope. I really do. That with a little bit of our input from the old farts of the internet, that they will put out an upgrade soon that sings and dances and lives up to their commitments and will be a better router. And I've been recommending Cake because that works best with FaceTime and other things. It's totally different. But, all I had to just let me into this damn thing and I can fix it for you. And all of it. It's not just me. It's not queuing. There's IPv6 stuff. There's Samba. There's all the wonderful things that OpenWRT can bring to somebody that's in Timbuktu. Matter of fact, this gives me another segue. So it would be really wonderful if I managed to annoy or at least help out. I really care about space. At least help them on their road to do that. And if I get a tweet back, my boat needs a new motor. A card, Christmas would be nice. And then we can move forward on that. But that gives me a really good segue, I think. Am I done though on this side? Good Starlink story. Yeah. And it goes back to the right to repair. We need to work in cooperation to build a better internet. Yeah.
Yeah, I was going to say this is the thing that's on the inside of that, and you're not going to be able to see it, but there's a little tiny header there that if you have amazing soldering skills, you can solder onto and probably break into this. But man, that is way beyond the abilities of most people. And I agree with Dave. Starlink is still in beta. We're hoping. I think all of us that use it are hoping that some of these things get fixed and that router gets better because. Really, that router is pretty terrible right now. There's a reason that the board from my router is out and not plugged into my network.
It doesn't do IPv6, and it's hard. It really is hard to make IPv6 work. So I want somehow for them to. Elon did one wonderful thing in the early days of Tesla. He took all the patents for the battery technology and said, "Here, this is your battery. This is our battery." And he said, "Go use that." And my plea would be, please engage with us. The open source community, and we will help you build the greatest internet system ever, and get us humanity into space. We want to help. Please let us help.
Isn't this essentially the song that open source has been singing ever since the beginning? Look. We don't care about all of this stuff. We just want to fix there's this problem and we want to help you fix it. Just let us help you fix it. That's what open source has been about for forever, isn't it?
Yeah. I got a song about that. I got a song called It GPLs Me. Do that today. I wanted to segue to something else. Go
ahead.
Okay. So here's the whole COVID thing. Now, I've been self-isolating on my boat. And I'm kind of used to it now. I like my boat. And video conferencing a lot, and I really enjoy having company. But there's a lot of people in the world today that are still stuck at home, really, really stuck at home. India, is almost everywhere. But most recently, I started up a project to help out India, the country, and I call it Upgrade in Place. You're stuck at home. There's a link, I hope they're there. Go upgrade your junked router in a junk bin that you have somewhere and give yourself better internet. Take 15 minutes out of your life and do that. And then when you're done, go do it for your neighbor. And then maybe the two of you go do it for a couple more neighbors. And if you do the math on that one, I would have upgraded the whole internet in 30 days, my hope was I could somehow, the Rural Broadband Fund has distributed billions of dollars to people digging trenches in the ground. And can I get $10 routers and get people to reflash them and give them to people, stuff like that. So I wanted to put out a plea for you to help your neighbors no matter where they were, to have better internet while they're stuck at home. And I'm going to try to somehow get traction on that in the next couple months. So I still get a little emotional. It really sucked being stuck at home this past year, and it's going to continue to suck for a lot of people. So do that. So we switch one more time because I don't know. You guys talk for a second. I get it.
Okay, I can pick it back up. I think it's super important, and there are. It's interesting that when things happen in the world, like the pandemic, it kind of reminds people of, I guess, how much we do rely on technology and the internet. And it's interesting to me that things like open source are kind of the unsung heroes sometimes. And I think it's a great idea to try to get. If there's this way that we can fix things, you fix Bufferbloat and things start working better for people. I think it's a great idea to push and try to make that more. Well, really, I mean, what you're doing is you're trying to make it more accessible to everybody by having a broader mind share. People know about it, and I think you're right. Almost everybody has an old router in a drawer somewhere. I mean, you could go back to the original Linksys WRT54G, kind of the router that kicked all of this off, and you can put OpenWrite on it. Well, you got to go to an old version of OpenWrite, but you can put it on there and make it work.
Yeah. Well, I hope that somehow we get there. That just can go fix it for yourself and go fix it for 2 more people. We got IPv6 working. I don't know. Long story. And I want to shift to one other thing. Again, how much time do we have left, guys? I've lost track.
Got about 5 minutes.
Okay.
About 5 minutes.
I want to do one more picture plug, and then maybe you can ask me one more question, like ask me anything, I guess, random. But I wanted to pitch something. So I've been stuck behind proprietary video conferencing solutions. And I've been working on video conferencing tools my entire life. I'm blind in one eye and I'm deaf in one ear. And if I lose one or the other, I need to have some kind of assistive technology. So selfishly, I've worked on video conferencing tools for a long time. I worked in the IETF on it. And we did all these standards for the web browser. And then in the last couple of years, boom, you have to open the Zoom app, or you have to open Google Meet, or you have to do this. But no, the code and the standards are all open source, damn it. And you're doing all these layers of stuff. So a friend of mine, Julius Krobacek, in anger, started writing a new video conferencing server called Galen, galen.org. It's in pure Go. It's a beauty to read. It takes 10 minutes to set up. And you never have to go to Zoom again. And it also has about half of my, again, there's a lot of people, about a half of our buffer congestion control algorithms in it. So in my opinion, it works a lot better than anything else out there. And 10 minutes to set up. I mean, the longest period of time is actually getting to where you can get a certificate. And I'm hoping that, because now that it's open, I can actually take a look at it as a theorist, what else is going wrong with video conferencing and continue to improve it, because it's open source. And there's one more major feature that I really want, but this conversation has been great because you let me dominate. But I've been stuck in so many conversations where I wanted Robbins' Rules of Order to work, where I wanted one. The timer went off. T minus 30. You have 30 seconds left to make this point, and then have the algorithm shut that person up. And I know it's selfish of me, but I like. Again, it goes back to fair queuing. I want to be able to have one person talk, another person talk, another person talk, instead of having someone drone on for 27 minutes. So I'm hoping to leverage Galen in this way to improve it, get more people helping. And also the most important part to me is that Galen runs on hardware as weak as a home router, which means you can send video from upstairs to downstairs without having to engage the KGB, the NSA, your ISP, anybody else. You can be on the internet to send video around your house. And I please go forth and install this and stop spending money.
So it's interesting. We use a combination of things for the show here, but whenever we can, I always ask to be able to, for my part of the call, I always ask to be able to use OBS Ninja, which is another one of these open source video conferencing solutions. And I just have to stop and say, I think it is super important and really great that there are solutions out there like Galen and OBS Ninja, where people are giving at least the option to have control back to individuals. as opposed to the big corporations. Like I better not say that. I don't have anything against corporations, right? Like we're not going to get political here, but it's super important that there's also the option for individuals to be able to run this stuff themselves, right? And so I think it's amazing to have something like Ghislaine also out there.
Well, I'm just glad I could tell more people about it. It's the most exciting video conferencing technology I've had a chance to work with because I can fix it. So, cool. Anything else for asking anything?
Yeah. So, Dave, we're getting into the closing moments here. And we always end with 4 questions. The first of which is actually, you've asked yourself over and over again, which is what we asked you. So if you have a brief answer to that one, we could start with that. Is there anything we haven't asked you you'd like us to have asked? And so that's, we could start with that and then go into the other few.
Oh man, Doc, can we just skip that one?
No, we'll skip that one. Okay, we'll go to the next one, which is, do you have anything to say about blockchain? And it could be 2 words or less.
See, again, there's another one. Blockchain involves a long duration upload to work correctly. And all the early blockchain algorithms made Bufferbloat worse for everything else. So a transaction that should have taken a split second to clear would take tens of seconds. So all the blockchain people, with all the millions of semi-fictitious dollars that they've made with it, if they just make a little investment in making the routers better, it would work better. That's again, I just care about the queuing portion of blockchain.
That is one of the best answers I've heard, and one of the most appropriate answers for our listenership here, because that's the kind of thing they care about. Okay, so the last 2 were, what are your favorite scripting language and text editor?
What is your favorite color? The answer is Max user to the core. I can't use anything else. I can't use any Apple products are completely impossible for me. Emacs. As to scripting language, what's that? Don't people still write everything in C? What's wrong with C? What's so wrong with C? It used to be Perl, and honestly, I really have degraded to where I just use shell for anything involving scripting. Awk, shell still works for me. I'm fairly old-fashioned, so more.
No, that's great. You're reminded that Phil Hughes, who started Linux Journal, where I worked for half my life or more, loved awk. He was one of the great proponents of awk. So, and he'd yell at people. What you did with 5 pages of Perl, I could have done with a page of awk. There you go. You have an awk song.
I'm horribly out of tune. Oh no, I'm not doing any songs today. But, hey, in addition to what I do, I play guitar and piano, and so you can find songs like "It GPLs Me," and I've wrote a song about SpaceX called "One First Landing," which is fun. And I have. If anybody needs an old computer geek that likes to play guitar to hang out at a party, it's only $50 an hour. It pays better than
you're in the Bay Area, right? So
I'm playing all over now.
And you're on the water there. David, has been so awesome having you on the show, and we're gonna have you back, and we'll be talking anyway. And I'm looking for progress on all of these topics, and there's so many of them. I know you're a little bit nervous coming into the show, but man, you have just been great and relaxed and on topic and all the rest of it. So I just really.
And Doc has been knowing you I've known you for over 25 years, and you've done so much great work for the Linux community. And Jonathan, I love what you're writing in Hackaday, and I hope that we can coordinate on a few interesting.
I'm sure you can.
Look forward to it.
So Dave, we'll have you back. Thanks so much, man.
Okay, thanks, man. Bye, everybody.
So Jonathan, that was awesome. That was one of our best shows, as I expected. And so any parting thoughts on that one? Because there's so much. I mean, we are going to have those commands that he mentioned. You just ran through them. I was trying to write them down. for Bufferbloat and some other topics. So we'll try to get those into the summary or somewhere.
So I was thinking there at the end, we asked him what his favorite scripting language was, and he basically told us that he does everything in Bash. Well, that's what Brian Fox told us, the guy that wrote Bash. In fact,
was it last week or the week before? I know.
Yeah, a few weeks ago.
I know. Asking Brian Fox what he uses is a little like, hey, God, what kind of lightning do you use? It's like...
Brian was a little offended when I suggested that Bash wasn't really a scripting language. He's like,
I know. Wait a minute.
Yes, it is.
Yeah.
No, talking to Dave is always great. I had a call with Dave last week where we went over some of this stuff, and he did better today. But sometimes talking to him is just like trying to drink from the fire hose because he's got all these different things going on. He's excited about all of them. He wants to tell you about all of them. He's trying to get out and change the world. It's great.
Yeah, he's been so great, and I'm so next. Boy, there's so much going on. And so go ahead and plug what you need to plug, and then I actually queued it up so I have who's going to be on next week. So I almost never do. So there's Hackaday right behind you.
I finally got my hand. I finally got my hand on a couple of these guys. This is the PoE Plus hat for the Raspberry Pi. Works on the Raspberry Pi 3B Plus and the Raspberry Pi 4, and it gives you a whopping 25, let's see, what did I test it to? 25.5 watts to play with, which is a lot. It lets you do things like, if you see the cyberpunk purple behind me, run LEDs over nothing but an Ethernet link. In fact, all of that is going over just this guy right here. It's just, there you can go. All you've got is the PoE going into it, and it's running all that light. So that is available over at Hackaday. It went live today, my review on this guy. So go check that out. And then Friday mornings, of course, the security article goes.
Fantastic. And I will, let's see, I got this done. Yeah. And so I'll plug for next week. Another old friend, Martin Mikos. He's been involved in so much stuff. It almost doesn't matter what I can do to plug him. So, that's Martin Mikos, Mickos, and that'll be next week. So thank you, everybody. It's been an awesome show. I'm Doc Searls, and we will see you next week on FLOSS Weekly.
Hope you enjoyed that episode. If you would like to laugh while learning about how to take control and take advantage of all of the features that your iOS devices provide, then you should check out iOS Today. The show Rosemary Orchard, my co-host, and I, Micah Sargent, host every week on the TWiT network. It's all things Apple all the time.